All right, peeps, here we go. We're going to try doing these notes kind of like this. All right. So, Chapter 4, Water, Food Production, Systems and Societies. I've got this window down open here, not that it matters, just because in case there's anything I want to show you. Introduction to water systems. Here's water budget. Think of a budget as like, like when mom gives you an allowance or something. You're on a budget. All right. Meaning like I don't care if it's you get paid $20, or $20 a week to do something, that's your budget. So out of that $20, you might have to, spend $10 on grabbing some candy, which maybe you put $10 in your bank account or something. So budget is just the amount of money you can afford to go out. So Earth's water budget, there's only so much water we can really afford to take out and use. So introduction to water systems. The Earth's water budget equals estimate of water in the water cycle. So you can only use so much of the water in the water cycle. You really can't use salt water that much. You can use it for some things, but generally it's pretty useless for us. Water that's locked up in glacier ice is not readily available, although we do get major side benefits from it with ice caps in glaciers. They're very important to us. 70% of the Earth's surface is water, which sounds like we're a bunch of water-rich peeps, but reality is not much of that water is very useful to us directly. Like Earth's oceans, they're salty, but they help cool off a lot of our climate, which is important. 97% of water is ocean water. So out of that 70%, most of it's from the ocean. Yep. Of that 3% of fresh water, 68% of it is locked up in glaciers and ice caps, which is super important because as the sun comes down, it hits those glaciers or ice caps and reflects and goes right up. It helps keep our temperature of our climate cool. And 30% is in groundwater. So that means it's locked up kind of underneath the earth, which is good because then it doesn't evaporate as much and we can tap it and have access to it. And there's other reasons for it. So if you do the math out, that leaves 2% for surface water. Very little of the water is in the atmosphere. All right. So lake, river, and swamp only make up 0.3% of the total. So yeah, what you see in like your local lake, river, swamp, 3%, it's 0.3% of the Earth's total water. Yeah, crazy, right? Turnover times for water molecules are interesting. Oceans, 37,000 years. Ice caps, 16,000 years. Groundwater, 300 years. Hold on, I gotta answer this phone. Hey, how are you? Is who? No, this is Soar. This is Dr. Soar. Gotcha, bye. Do better. All right, wrong number. All right, rivers, 12 to 20 days. All right, so when the water enters the river, it's only going to be there for 12 to 20 days before it gets sent out to the oceans. In the atmosphere, when it evaporates from the oceans and goes up in the atmosphere, it's only there for 9 days. So, yep, then before it becomes rain. So, do me a favor, explain one of the turnover times above in your own words. So, I'll help you out with that if you want, if you're listening to me. Oceans, that water stays in there for 37,000 years before it gets evaporated into the atmosphere, where it stays for 9 days. At the end of that, it is going to precipitate down. We'll say it comes as snow and then forms into ice with the ice caps. It'll be locked up for 16,000 years. The precipitation that falls into the ground will eventually go off into the rivers, will stay for 12 to 20 days. Any of the water that hits the ground will go underground and will stay there for 300 years. So the oceans is where our reserve, where we keep most of that water, where it stays locked up. Ice caps is another big one. All right. Crazy thing is, water can be considered renewable or non renewable. Renewable if it's in the atmosphere, rivers, and lakes. All right. Non renewable if it's in the ice caps and oceans. Just because you really, once it's the oceans and ice caps, it just stays locked up there for so long that you don't really have access to it. Um, don't get me wrong, you can have desalinization plants, and there's also ways you can do with the tides with the ocean where you can harness that energy. But for the most part, it's non renewable. Aquifers is somewhat renewable, but it can take longer than a human lifetime to replenish. What I'm going to have you do is please define what an aquifer is. Generally, an aquifer is like, in my words and the way I look at it, it's underground rivers or an underground water supply or reserve that spans quite a massive area. Um, the problem is once you overutilize it, it takes forever to replenish. So in the Midwest, if our farmers draw out all the water from the aquifer, it's going to take a lifetime, a human lifetime, for it to really replenish. Uh, the water hydrological cycle, solar radiation and gravity power it. So you basically, solar radiation evaporates the water from the ocean. It goes, those clouds then go over land where gravity pulls the rain down and it hits the ground, and then gravity pushes it back out to the ocean via the rivers, and it drives the weather. That's another major thing. In the water cycle, water is either in storage or in a flow. Flows can be transfers or transformations. Transfers are when it is in the same state. So if it's rain, rain, um, water's water. However, there's also steam or evaporation and ice, flooding, surface runoff, infiltration, and percolation. Right there. Transformations is when water changes state to or from liquid. So if it's evaporation, ocean into the atmosphere; condensation, atmosphere into rain; freezing, uh, into snow or ice; storages. Um, Storages is where the water can be stored. It can be stored, obviously, anywhere where it's really held for a while. So, oceans, soil and groundwater, yep, it's there for years. Glacier and ice caps, again, years. Lakes and rivers, stored there only for a few days, we know now. In the atmosphere, it's there for 9 days. So, not there long. Um, what I'm going to have you do is draw the water cycle and label the storages and flows below. I'll try making this a little bigger for you. Yeah, that's about right there. So you're going to draw the water cycle. When I say draw the water cycle too, it's looking like this. Water cycle, Google search. We're going to do images. You can pick any of these images up here, and they should do just fine for you. All right, you have to draw it out on your notes. So once you have it, make sure your image has snow and ice, groundwater and aquifers, lakes and rivers, an ocean. You can show the atmosphere, soil, and then you can show these different flows: precipitation over the ocean, like rain over the ocean; precipitation over land; ice melt; and then surface runoff; evaporation from land; evaporation from sea. Then list the 6 storages from greatest to least. Which of these storages can humans use and how? Storages we can use are groundwater and aquifers. We use them to irrigate plants and for irrigation. Lakes and rivers we use for energy, also to control floods. And that's pretty much what we have. So, all right. Human impact on the water cycle. Humanity has always changed the landscape and interrupted the movement of water for the benefit of humanity. Think of dams. Withdrawals, household use, irrigation, industry. So we draw water out of reservoirs or even the aquifers for household use to wash dishes, flush toilets, all that sort of stuff. We do the same for crops as far as irrigation. We draw water out, we bring it to the farm, and there's different ways to irrigate, which is rather interesting. But yeah, that's how we use it. And also for industry, we use water for energy. We also use it for washing things and whatnot. There's a lot of water that's used in manufacturing. Discharges, adding pollutants, agricultural chemicals, sewage. So unfortunately, like a lot of our pollutants just get washed away, and that then goes into a river, which then brings it out to the ocean with the idea that eventually it evaporates or over time just goes away. Agricultural chemicals are no different with this, whether you're talking about pesticides, herbicides, or fertilizers. Big problem in Vermont, because you use cow fertilizer, cow poop, spread it over the fields. The only problem is when it rains, it washes all that fertilize, like that cow poop and the nitrogen, into the rivers that then flow downstream, eventually end up in Long Island Sound. And that fertilizer really has an effect for like algae blooms and other things. So what makes it great to grow crops also makes it great to grow other plants and life that is not as desirable. So sewage as well. So obviously when you flush your toilet, that's that can be kind of toxic. All right. Hopefully, the idea is to treat it so that it's not as toxic, and that before reintroducing it to rivers and whatnot. Changing flow, speed, and location. We do this with dams quite a bit for floods to control it, also to conserve water and form those reservoirs. Diverting rivers, we do this quite a bit for different reasons. We bring water from one location where we have a surplus over to where we have more desire or need for it. So, this should be highlighted in green. All right, let me do that there. Look up photos of the Aral Sea and tell me what you see. Also, too, this one here. All right, look up when it rains. Look up when it rains. What happens and what is the difference between the playing fields and the parking lots? Playing fields are flat and grass, so when the water hits, the water stays up top and gradually just percolates into the ground, aquifer style. Now, when it rains on the pavement, it just hits the pavement and just instantly goes washing off, or on top of the building and goes into the gutters, and then goes out to the streets where it goes down into the drain, straight into the river, and washes right off. So one problem you have is like in very urban settings, when it rains, there's these flash floods because all that water goes straight out and can cause problems. Urbanization, flash floods. Wow, think of that. Um, Urbanization and flash floods. When rainfall or snowmelt outpasses soil's ability to absorb it. That's interesting because the reason why snow is so important as opposed to rain, like for California, um, you can have precipitation like rain, but the rain falls, it hits the ground, and then all of it all at once goes right down the mountain, right down into the drain, right out to the river, right back out to the ocean. None of it gets really held up for human use. Where snow, on the other hand, their farmers used to say it's the white stuff that makes the green stuff. A lot of farmers plow, so there's another reason for that. But the snow, when it falls, it brings nitrogen down out of the atmosphere. But two, it it gradually melts. So you don't have this massive rush of water that then just the rest of the time you're water poor. So the snow gradually melts. It's like the snow's like water in the bank for them. And it really gets saturates the soil. So the soil is like water dense and it gets in the aquifers, prevents forest fires. It's really like if you ask any farmer, really snow is more beneficial to them than rain. So occurs in areas with a lot of cement, asphalt, or dry baked earth. This is flash floods. So when you got a really hard surface, like dry, really baked soil, like during the summertime, or asphalt or cement, and it rains, again, it just goes right down the drain. All right, below is a map of our school in red and a cleared forest area where they are making new apartments. What will this do when it rains? All right, let me make this a little bigger. Dang, all right. So here's our school right here. And here's where they're clearing out what used to be a forest, which would, lock up carbon in trees and be very good and have wildlife and nature and, diversity of species. And they basically just clear cut, the forest out of there. They're going to obviously plant grass, but a whole lot of like driveways and pavement and blacktop for parking. And because of that, what do you think is going to happen when it rains? Where do you think that rain is going to go off to? And oh, yeah, if you can follow that blue arrow into that, it's probably a good idea. All right. And tell me what happens to that area. So, yep. Ocean currents and energy distribution. Let's get that right to about there. All right. Ocean currents is movement of water vertically and horizontally. So ocean currents go this way, like across the globe, but they also go down underneath, like deep into the ocean, and then up to the surface. So they're not specific and not random. So the same currents are pretty much always there. We notice a pattern with these as like hundreds of years have gone by with exploration and fishing and whatnot. Like seamen, like people who make a living on the sea, they notice these currents big time. Surface currents is in the upper 400 meters of the ocean, and they are moved by wind. So if you have a hurricane, it really has an effect on the way the waves go and the wind. I will show you something with this. Let me look up right here. Rincon, Puerto Rico. All right. We're actually going to go to maps. All right. So right here is Rincon, Puerto Rico. Rincon is, I think in Spanish means corner. So this place is crazy for waves. All right. And the reason why is because as you have like all these, and it's really crazy for waves November through April, because November through April you have all these storms that come in across the United States. They come down to the Gulf of Mexico, they pick up moisture, and then they get out over here over the Atlantic. And what they do over the Atlantic is the wind just goes boom, 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 boom to the ocean. It presses down, and that creates like, if you've ever whipped a cord, you see how it like goes all the way across. So that sends like pressure on the water on the ocean all the way down here. And by the time it comes down here and gets to here, like that pressure on that water creates these massive waves that look something like, let me get out of Google Maps. Maybe I can go back. We're going to go back one more. We're going to go to images right here. Rincon, Puerto Rico, surfing. And the waves look something like this, which is pretty good. All right, I think we can look up Tres Palmas, Puerto Rico, surfing. All right, let's see if we get a gnarly break there. Yeah, you get these like massive waves like this right off of Puerto Rico. So that's why a lot of surfers love it. Anyway, back to this for a second. Um, so that's why surface currents are moved by the wind. All right. I'm sorry. The upper 400 meters, the surface currents. Deep water currents make up 90% of all currents. They're caused by water density differences from temperature and salt. So the saltier the water it is, the more dense it is, and the more it drops down. The less salt, it tends to be up top. So as you can say, like deep water tends to be saltier, you know. Also too, temperature as well, because if it's cold water, it's going to drop down low. Warm water tends to stay up high. Um, Warm water holds less salt than cold water, so it rises. Yep. Okay. What oysters have more brine, salt, Caribbean or Massachusetts? Think on that one. Think about that. Warm water holds less salt. So if you're going to eat an oyster in the Caribbean, would it hold more salt or less salt? If you're going to eat one in Massachusetts, would it hold more salt or less salt? So, upwellings, cold water coming up from below to replace warm water. That's where it goes and comes on up to replace warm water, which, because if here's the warm water and it moves out this way, the cold water is probably going to come up behind it. So it makes it like a cycle. Down dwellings is where hot water going down to replace cold water. So as that hot water comes across, it's then going to drop as it gets less hot and become, so it's all that cycle. Cold water currents go from the poles to the equator, and warm water currents go from the equator to the poles. Why? Because the poles are cold and the equator is warm. Ocean currents and climate. Let's bring that up a little bit to like right here, right there. So it takes more energy to raise the ocean temp than it does land. All right. Of course, once that ocean temp is warmed, it has more of an effect and good luck cooling it off. It takes longer to cool off, too. Water heats up and cools down more slowly. Coastal communities have more mild climate because of this. Like if you're on Cape Cod in Massachusetts, there's years where you can play golf all year long, even in January. And you're like, how the heck are you in Massachusetts playing golf? Well, it's because that ocean is on two sides of the Cape and it keeps the Cape somewhat mild, warm. All right. Um, El Nino. El Nino is in Spanish the little boy. Um, Southern oscillation, ENSO. But this doesn't really refer to the little boy. It refers more to like the Pacific Ocean water temperature and what it does to currents. It happens in the Pacific and it has global effects. Like El Nino and La Nina literally control a lot of our weather globally. So, normal air pressure is higher in South America, like on the western part. We're talking about Peru, Chile, Andes, stuff like that. So normally there's a higher pressure there than there is in Australia. The result is that the wind blows all that nice warm water from South America all over to Australia, which is generally how like we like it. That's La Nina. All right. Um, El Nino is the reverse of this. All right. So El Nino is basically where the wind and water direction it changes, and it tends to go more east to west. This occurs every 2 to 8 years and lasts about 2 years for El Nino. This locally destroys the anchovy fish industry, and it kills a lot of seabirds and lots of storms in Peru. Why? Because we'll get into the why it's so rich there for anchovies in Peru in a second. But obviously, when you got warmer water that comes in, like that affects the fish, less food for seabirds, less food for seabirds. Seabirds come down with a bad case of dead. So, and also too, that warmer weather that comes in tends to bring storms with it. So Peru really gets nailed with some big time rain events. Normally, oceans are not productive because of low light and nutrients. just the way it is. Not a very productive habitat. Um, the thing is, though, ocean, and it's also too because the light and the nutrients are in different locations. If you're the ocean surface water, this has got more light, but not very many nutrients because those phytoplankton go and eat them all up. All right. Now, what happens is like whatever nutrients there are goes and falls down to the deep ocean. Where so the deep ocean has a lot of nutrients to it. Not a lot, but it has the majority of the nutrients. Unfortunately, there's no light that gets down there, so they're pretty useless. So nothing can really grow down there. Um, just the way it is. So why this comes up is Peru has the deep Humboldt Current, which replaces warm water with deep, cold, nutrient-rich water. So the Humboldt Current comes in like this, scoops up all these nutrients in that like cold water and brings it boom right up to the surface where a lot of those fish are like, oh yes, all these nutrients. All right. And then because the fishies are out there like living their best life, there's tons of them. Guess what? There's tons of predators known as seabirds that come in and then they eat all the fishies. So not all the fishies, but the birds have got some pretty good pickings there. Right up until the Humboldt Current goes away because of El Nino. El Nino shuts it down like it's the lunch line at like 12:50. It's just not going to happen. Um, so that's why, like, we're down here. El Nino rivers, no nutrients means fish and birds starve. It changes the jet stream can. All right. So once you get it locked up, it all like with El Nino, the Humboldt Current, no more Humboldt Current. It also changes jet streams. Now, because it changes jet streams, it has an effect globally. It causes droughts in Australia, Indonesia, and the Pacific Northwest, which then cause forest fires during the summer season when it gets hot. Storms and flooding in California and Europe. Yeah, that's right. Even though it's the Pacific Ocean on the other side of the globe, it affects Europe. Also, there's no monsoons in India when it's an El Nino, or just reverses them. How does El Nino and La Nina affect Connecticut or New England? You're going to have to look that one up on the internet, peeps. So, the Gulf Stream, North Atlantic Oscillation. All right. The Gulf Stream is the warm surface water from the Caribbean, travels up and across to Europe. Let's see if I can get a picture of this up here. Bet you that it comes up on, I'm going to choose map because the Gulf Stream can also be in a trailer you tow behind the car. Like, all right, so here's your Gulf Stream. What is the Gulf Stream? Noah. Yeah, right here. Gulf Stream, you got that warm water from like all the Caribbean, Gulf of Mexico. Oh, yeah. And then he brings it up this way. It brings it on over to Europe. By the way, a lot of this has to do with like trade winds too. If you start looking at the triangle trade, if you're into history, and it's a sad part of history. Europeans would take ships, come on down to Africa, pick up natives in Africa, bring them across right by the Tropic of Cancer and the equator because you had that trade wind, drop them off in the Caribbean as slaves, and then would ride the trade winds on up. And they bring from the Caribbean rum and sugar that they would then drop off in New England for timber and pelts and hides, and then bring them back Gulf Stream style over to Britain, where they would then trade those pelts, timber, hides, also some sugar and the molasses, whatever's left over, for, and then in the Europe they would make those they'd take those raw products and make finished goods out of them for manufacturing. Kind of that's how the trade kind of went, and you can see it's off by nature. So, all right, back to this for a second. All right. So that warm water from the Caribbean travels up and across to Europe. And the North Atlantic Oscillation, that's like the surface water, the the Gulf Stream. The North Atlantic Oscillation is the under part of that, where it goes underneath to replenish that salty I'm sorry, that salty warm water that's coming up from the Gulf. The North Atlantic oscillations, cold water, really from like Britain, Scandinavia, Norway, all that stuff, where it just goes, where it starts coming across, gets salty and cold, drops down, and then goes right back in a loop, deep to the Caribbean. Um, the problem is the Gulf Stream is slowing down. And this, they're thinking, is because the Greenland ice caps and glaciers are melting, which is dumping a lot of fresh water into the Gulf Stream. So the Gulf Stream is no longer going to be as hot, and it's not going to be as salty, which means that the return of the North Atlantic oscillation is less likely to move and move slowly. And because that water is slow to return to the Gulf of Mexico, it's going to be even slower getting moving on up into Europe. So, which is a major problem. So, all right, peeps. Hopefully you enjoyed this, and hopefully you're doing awesome. Catch you later. Bye.